Welcome back to Further Solutions Academy. Further Solutions Academy. At this point, you can come to our channel and learn any topic of your choice: mathematics, physics, and chemistry. Don't forget to share the video across and also subscribe if you have not subscribed for direct updates, and also contact us for our online classes also. On this video, I'll be working on matrix transformation. Now, outline of this video, these are the outline. Number one will be conditions of what? Matrix transformation, matrix representation, and the examples. This example, I think it may give us more video on example. By the end of this video, you will understand. I may not do more of this example, but I'm going to be, maybe it will be a continuous on the next video. Okay, let's start what I need to start on time so that I will be able to get to where we are going to. Now, I have something like 1 year what you have been a word linear transformation by now. Before you watch this video, try to watch your mapping and function. Is very, very important. Now, when we talk about linear transformation, for instance, if I have a given matrix, like I have my A equals to -3, 7, 1, and 4 is 0, 3, and 2. And now I have my heads, and my heads can be 1, 1, 1, 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay. 1, 1, 1. Okay. Which is going to be my 1. Now, if I have my AX will just 2, 3, 2, 1, and 4 is 0, 3, 2, and my X is 1, 1, 1, 1. Which, when I do this, it will be AX will be equals to this plus this plus this plus this. It will give me 7, and this plus this plus this plus this. It will give me 9. That is my AX. Now, what I'm trying to explain here is that my T of R of N to what? Of R of N, can't you see? That is what we mean by what? Now, what I'm trying to say is that this one, we call it domain. Now, why this is called codomain? Codomain. Please take note of that. Take note of that. That is codomain. Now, can you see what I mean by linear transformation? Now, can you see that is what is called transformation? This to this. Now, one is image, and the other one is called pre-image. By now, you should understand that very well. Now, what I'm referring to, what I'm trying to do here now is my. Can you see that? I can see that my X. Sorry, permit me to write my X to what? My AX. My X to what? AX. That is what I mean. Which is going to be what? Image and pre-image. Image and pre-image. Now, like by doing that, let me try to show 1 or 2 examples. Look at this particular example. I won't like gray marker. Squared to what? R of 2 be a transformation defined by T of xy equals to x 3, 5x 5y, and I have this is, sorry, let me put this like this, and I have minus x plus 7y. Close the bracket. Now, okay, now having this, look at me. What I just need to do now is that it's not hard. It's not what? It's not hard. I want to have this. What I just need to do is that I will just have my f of my, this is going to be the transformation. I have s minus 3y, this is 3y, sorry, 3y. Now, I have 3x plus 5y, and also I have minus x plus 7y. Now, this is what I'm saying here. Now, what I just need to do, I'll be having 1 minus 3 and 3 and minus 1, and here will be 5 and 7. That is what I mean there. Now, which I will now be talking about what? I'm talking about t of x, which is now become what? X and y. Now, I can now make this as m what? Of x vector. Now, this is my m, this is my n, and this is my what? My x, which is the vector. Can you see the matrix and the vector? That is what I need to, or you need to understand on this part. Now, let me try to talk about the condition now. Condition. I need to get a good marker. Now, I need to have a marker here. Now, let's talk about the condition. Condition now. Conditions. Now, if you talk about the conditions, number one, you must understand that if I have t of u plus v can also be represented as t of u plus t of v. Don't forget that for all u, this marker is not very good. Okay, for all u, for all u v belongs to what? Vector, which is very, very important. And for all u v in the what? In the domain. Let me just, for all u v in the domain, which I've explained that. Domain of what? Of t. Now, which I've explained that. Now, by told you that, you understand that what I mean. That is number one. Number two, condition number two, if I have t of c v, now this can also be represented by c of t v. Now, this is a scalar, this is a vector. I think once one will come out of that, and I think c belongs to what? Scalar, which is c belongs to what? Scalar, and v belongs to what? It belongs to the domain, which is going to be t, belongs to the domain, which is domain of t. Now, by so doing, these are the conditions that I will be working on as far as this video is concerned. Now, before we talk about that, let me quickly explain what is called identity matrix. Now, that is very important before we also talk about that area. Now, if I'm talking about identity matrix, if I have I of 1, it means I'll be talking about 1. I of 2 will be equals to 1 is 0 is 0, 1. Now, if I now move on to I of, for instance, I of 5, it will be equals to 1 is 0, okay, is 0 is 0 is 0, 1, 2, 3, 4, 5. Okay, also this one will be what? 1 is 0 is 0 is 0, and is 0 is 0, 1 is 0 is 0, is 0 is 0 is 0, 1 is 0, is 0 is 0 is 0 is 0, 1. Now, that is my I of 5. Now, take note of this. If I want to make it to be very interesting, now, if I want to make it to be very interesting, I can now say that the columns of the identity matrix, which is I of what? Of 5, can be written as, now I can say that what? E of 1 will be equals to 1 is 0 is 0 is 0, 1, 2, 3, 4 is 0. Now, what my E of 2 will be now? My E of 2 will be 1 is 0, 1 is 0 is 0 is 0. Now, my E of 5, will be equals to is 0 is 0 is 0 is 0, and 1. Can you see? Now it means I'm just E of 1, E of 2, E of 3, E of 4, and E of 5. That is what I mean by that, and by that. That is what I mean there. Now, okay, by so doing this, let me try to show one or two examples that will really help to illustrate, to show, I think, with what I've said, mentioned now, you're able to understand what is called identity matrix. For us to transformation of it, which is going to be E1, E2, and E3. Now, before I go more deeper, let me try to show one or two examples. Okay, now let's work on this and let's see how it will be. Solution to this question. Now I have, let it be a linear transformation from R2 to R3. I think is defined, which is going to be image and pre-image, such that T of E1 equals to this, T of E2 equals to this. Find a formula for T of X where X is an arbitrary vector in R2. Now, if I'm to solve this thing, it's a very simple problem, which you all know. The first thing, I will declare my vector. My vector can be what? X1 or X2. And X2, that is my vector. Now, which implies that I can say that my X1 of E1 and plus X2, S2 of E2. Now, it means interpretation. It means I'm talking about what is going to be my X. I don't know it. It will be, which is 2 by 2. It will be 1 is 0. And plus E2, which is going to be S2 of what is 0, 1. That is what we are talking about. Now, since I have that, I can now say that what? My T of X will be equals to, my T of X will be equals to X1 of T of 1 plus S2 of what? Of T of 2. T E of 2. Now, since I have that, it means I'll be talking about, this implies my X1 will be, I have of T, what of my T1, I have minus 5, minus 7, and 2, and plus, this one will be X2, and I'll be having minus 3, 8, and 0. Now, since I have that, I can now say that, now it will now be what? It will now be, since I have that, it will be X minus 5, 5 this, which is 1, and minus 7x1, and I have 2x1, and which it will be plus, I'll be talking about x2. What is my x2? Which is going to be, I have minus 3x2, and 8x2 is 0x2. Now, which it can also be equals to 5x1 minus 3x2 minus 7x1 plus 8x2 and 2x1 plus 0x2. Now, can you see? That is what I'll be talking about. That is what I'll be talking about. Now, I think with this, you should be able to understand what linear transformation is. Now, let me try to explain what is called matrix representation. Okay, matrix representation. Now, what you just need to do, we are talking about T of EK, for instance, it will be equals to log T of E1 and so on and so forth. I can declare a constant A1, which is going to be a constant number, A1, A2 to what? Which is a linear combination of A of what? Of N, T of N. Can you see? This is a Now, can you see that is what we are talking about? Now, in implication, it means I will be talking about it's also run down and depends on what you are running. I'll be having T1 of T1. Okay, I need to make it clear, but I don't need to stress myself. If we are talking about that matrix representation of it, it's always like this. I have A of order, which is this one can be order of 1 1, and this one will be what? Order of n1. I can also run to order of n1n, and this also will be order of what? Nn. That is what I mean there. That is what I mean there. And that is what I mean there. Now that is matrix representation. Now I don't need to stress myself. Let me try to show example in order to avoid to be able to understand what I'm trying to say on that graph. Now, look at this particular problem. T of x, y, z will be equals to 2x, 5y, 4z, 3x, 4y, and x minus 7z. Now, if I want to write this in a find, let me just use the word find the matrix of T relative to the. Now let's see what is here. Now what you just need to do here is that I will just need to write this formula, which I have my matrix. Let me use the word M. My M will be equals to, I will be talking about 2 minus 5 and 4, and I'll be talking about 3 minus 4 and 0. This one will be I'll be talking about 1, 0 and minus 7. That is the matrix we are talking about. That is the matrix we are talking about. Can you see it's very, very simple and straightforward. Now, because of our time, in the next video I'll be working on examples on this part. I have 2 examples or 3 or more to work on. I think I will be stopping here by now because of our time. Don't forget to share the video and try to subscribe. Once again, thanks for watching.